Hi everyone, this is your video for rate of change. We're going to be learning about obviously rate of change, but also average rate of change, which is a little bit different. So here we go. So this should look a little bit familiar. This is kind of like a more elaborated slope formula. So the slope formula that you're used to is that m equals y2 minus y1 over x2 minus x1. And you can see that you're in a very similar format. You have an input, which is B, and then its output, f of B. So that's like your input, output. Input A, output. This is kind of how we're going to start viewing rate of change, just in regards of being able to think more advanced and for functions other than a line. So let's use this formula and we're going to find the slope or the rate of change between these 2 points. This should be fairly, familiar. This is something that you guys have done for at least a couple years now. And whether or not you wanted to use the a of x, which is the f of b minus f of a over b minus a, or if you want to use the m equals y2 minus y1 over x2 minus x1, you're going to get the same answer. They're both correct. So it's totally up to you. I just want you to be aware of the more advanced version of the slope formula. So here we go. My first thing I always like to do is to label. So I'm just going to use this form down here just because we already have points. And I'm going to label them x1, y1, x2, y2. Some of the littlest mistakes make the biggest problem. So you need to make sure that you're inputting this correctly. So my y2 is 16 minus my y1, which is 8. Over my x2, which is 9, minus my x1, which is 20. Notice how the ordered pairs that were paired up, so 20 and 8, are over each other. They're in the same position. If they're switched up, you're going to get an incorrect answer. So 20 and 8, and 9 and 16. So let's simplify this down. So we have 16 minus 8, that's going to be 8. And 9 minus 20 is negative 11. So this is okay if you want to write it like this. But generally you like to just put that negative sign on top, and there's your slope. Leave this as a fraction, okay? Because this is telling us the rise over the run. Hopefully that's familiar too. All right, let's do one more like this. So we have, let's see, so we can use the same formula. We'll use the m equals y2 minus y1 over x2 minus x1, and we can label our points. So we have x1, y1, x2, y2. I think that y1 looked like an x, but you know what I'm talking about. So we're going to plug them in. So we have our y2, which is 8, minus our y1, which is negative 13, over our x2, which is 17, minus our x1, which is also 17. So this actually ends up becoming 8 plus 13. Add a line, change a sign, whatever fun phrase you've learned in the past. But yeah, so negative minus a negative becomes positive. So 8 and 13, we get 21 over 0. Okay, so this is kind of an issue here, right? We cannot divide by 0. What this is called an undefined slope. So your answer is actually this word, undefined, not necessarily the number 21 over 0, because we cannot divide by 0. So we're going to do the same thing, and now this looks a little bit different, okay? So your directions here would say, find the average rate of change for the interval. Ran out of room there. All right, there we go. So they're giving us a function, they're giving us our interval. Now this interval, you can view this as your x1, x2. Now the big thing here is that you need to notice that these are brackets. This is not an ordered pair. This is telling us this is an interval. All right, so let's plug in those values. So first thing I just want to do is to find what f of negative 1 is going to equal. So 2 times negative 1 squared minus 2 times negative 1 plus 1. So we have 2 times 1 plus 2 plus 1, which is 5. So our first point is going to be negative 1, 5. And then we have our f of negative 1/2. So we have 2 times negative 1/2 squared minus 2 times negative 1/2 plus 1. So when you square a fraction, you square the top and you square the denominator. So this is really going to be 2 times 1/4 plus, and we have 2 times 1/2, which is 1, plus 1. So that's 1/2 plus 1 plus 1, so that's 2.5. I'm just going to leave that as a decimal. All right. Oops, wrote it in the wrong spot there. Let's see, we inputted negative 1/2, and then our output was 2.5. All right, so now we have our y1 and y2 along with our x1 and x2 that was given. We can use our slope formula, or you could use the average rate of change formula, and it's going to be your y2 minus y1 over x2 minus x1, which is going to be, let's see, so we have 2 1/2 minus 5 over negative 1/2 minus negative 1. Remember, it gets a little tricky there. I'm going to scroll up so we have a little more space. All right, so now we need to work on these fractions here. I know it's your favorite thing. So we have negative 2.5, right, because that's 2.5 minus 5, over, now this becomes addition again, and that's going to be a positive 1/2. So we're going to do a little bit of fraction work. Do not be overwhelmed with fractions. I promise you, they are more scared of you than you are of them. So I'm going to make this an improper fraction in our numerator to get started with. So that's really negative 5/2 over 1/2. And hopefully you remember, keep, change, flip. And that's how you divide fractions. So we're going to keep the top, change the sign, flip the bottom. So we have negative 5 over 2. We're going to change to multiplication and flip to 2 over 1. Hopefully you remember that these 2's are going to cancel out. And your slope, or your average rate of change, is going to be negative 5. Okay, one last problem that's nonlinear is we have this function, and we also have a graph, so it's kind of nice to look at that. And we're looking at the interval. Remember that these brackets mean that it's an interval. We're looking at the interval between negative 3. So I'm just going to put some dotted lines here so we can see where we're working. So we're going between negative 3 to negative 2. So sometimes graphs are pretty helpful because you might be able to get an exact point. This graph, not so much. This is a rational function, so it's not going to be as easy as like nice little whole numbers from a linear function. So what we can do is we can do the same process as the last one, where we're going to plug in our negative 3. Let's make that a little narrower. And we're going to get negative 1 over negative 3 minus 2. And that's going to end up being negative 1 over negative 5, which is just 1/5. So our first point is negative 3 and 1/5. And then our second point is when we plug in negative 2. So it's negative 1 over negative 2 minus 2. Be extremely careful with signs. Okay, negative 2 minus 2 is really negative 4. And this also becomes positive 1/4. So there we have our second point. We have negative 2, 1/4. So let's use our slope formula. Remember, average rate of change, or rate of change in general, is that same idea of slope. So if you can't remember that first formula, always feel free to go back to the slope formula. All right, let's plug in our values here. So let's label, because we didn't label them yet. So we're going to label this as our x1, y1, x2, y2. So we have, let's see, 1/4 minus 1/5. Ooh, lots of fractions in this one. Over -2 minus -3. Okay, get ready for some fractions. So 1/4 minus 1/5, you can find a common denominator. So their common denominator is going to be 20. So to get that, it's going to be 5/20 minus 4/20. And that's all going to be over, so -2 becomes a +1. So I really don't need to write that anymore. So we have 5/20 minus 4/20, which leaves us with 1/20. That is the tiniest little rate of change. But hey, you know what? It's still changing. So 1/20, that's your rate of change.